All right, so we are transitioning from data analysis to algebraic analysis, okay? In math, there are four main branches of math. There's geometry, there's algebra, there's data and statistics, and there's number theory. In data and statistics, the type of graphs we deal with are box plots and histograms and dot plots and those types of things, right? Frequency tables, stem and leaf. Data and statistics is when we gather a whole bunch of information and make predictions based on it, okay? Algebraic graphs, algebraic analysis is a predictive nature, but it tends to be only in one scenario. Whereas in data and statistics, there's so many that we collect and we analyze it and make an average, right? We find our average. In algebraic, it's just one scenario that we're dealing with at a time. So there are two types of graphs we're going to work with. Two types of graphs in algebra. The first type of graph that we're going to deal with today is what's called a continuous graph. Continuous, what do you think it means? It continues. It goes on forever. Mathematicians are not creative people, you guys. A continuous graph continues. It's connected. It's a line. It goes on. Here's some examples of continuous graphs. Have you ever seen a picture of what the stock market did during the day?
Yeah.
And it goes up and down.
Plummets.
Right, it goes down, sometimes it goes up. If it's going over like a year, right, there are big ups and downs. But in a day, it just kind of goes up and down. It's continuous. It's a line. You ever watched a medical show or been to the hospital and seen someone who's on a heart monitor?
Yeah.
And their heartbeat is a continuous graph. It's a line. Does it go up and down? Yes. But it
Continuous.
right? Continuous, connected, right? That's one type of graph in algebra. It's a line graph, basically. The second type is called a discrete graph. A discrete graph is a dot graph. It's made up of distinct points. It's made up of distinct points. If I am measuring the number of students who are in each of my classes, right? And I just keep adding a student. At first I have 25 students, then the next day I have 27 students, and then the next day I have 32 students, and then the next day I have 28 students, right? I'm measuring my attendance in my classes. Those are distinct points. If I'm measuring how much money I have, I'm collecting money, right? I'm putting money in my piggy bank every day. And the first day I have $1, and the next day I add another dollar, and the next day I have another dollar, and the next day I have another dollar. Those are distinct points. Nowhere is anybody sneaking in and secretly putting money in, right? I'm physically doing $1 a day, so there are distinct points. Distinct points, discrete graph. So you're going to be getting some scenarios. We're going to be graphing them. Meaning they're going to give you a story and you're going to have to create a graph that mimics that story, that shows that data. Here's a very simple story. Simon sells candles for $2 each. He sold 4 candles. Can you make a graph of what happened to Simon?
Yeah.
Simon's got this stand. He's got a storefront, right? Sells them out of a cute little stand at the farmer's market. Simon sells 1 candle. What happens?
$2.
He gets $2. Simon sells another candle, so he's now sold 2 candles. How much does he have? Simon sold 3 candles. How much does he have? Can Simon, should this be a continuous graph or should it be discrete? So you're telling me Simon has the potential to sell 1.4 candles.
Yes.
No, Simon sells 1 candle. And then he sold another candle. So now he's sold 2 candles. He's not going to come home to his wife and be like, well, today was a really good day at the candle selling stand. I sold 11.17 candles. Right? If you went up to Simon and you said, hey, Simon, I want 1 candle, what's he going to say? That'll be $2. 1 candle is $2. If you went up to Simon and you said, hey, Simon, I want 2 candles, what's Simon going to say? That's $4. If you went up to Simon and you said, Simon, I want 2.7 candles, what's Simon going to say?
Get out of my house.
Right, get out of here, you crazy pants. I don't sell 2.7 candles. You can get 2 candles or you can get 3 candles. Nothing else. Right? Selling candles is a distinct, individual process. You cannot say, oh, you know what? I love this jacket.
Okay.
It's $40. I only have $30, but you know what? If I cut the sleeves off of it, I bet they'll sell it to me for $30. Because I cut off $10 worth of the coat.
That doesn't
No,
work.
they make you pay for the entire thing.
Correct.
It makes you pay even more because it's a vest.
So, you distinct points, right? You cannot have an in-between. It is a specific for each activity. That's a discrete graph. What about this story? Julie is running a race. She runs the same pace for 4 minutes, whatever, right? I'm not putting a lot because you'll whine about writing all of this. Then slows, she got tired, and sprints finally to finish. Julie is running a race. She runs the same pace, and then she slows down. She's tired. And then she thinks, oh, I'll just finish, and she sprints to the end. This is set in real world America on planet Earth with the technology of October 5th, 2017. Julie is not attending Hogwarts. She cannot apparate.
But does she have robotic legs?
She may have robotic legs, I don't know. But she can't teleport. She can't apparate. She can't.
Turn herself into a skull.
I mean, like, right? Julie's race, is it discrete or is it continuous? So you think Julie is right here, then bam, she's over there.
Yes.
No, how does Julie get from the front or the start to the end?
Moving.
She goes every single thing, right? If it's from here to the wall is my race, how do I get there?
You run.
I have to cover every single thing, right? Can I run 1.1 miles?
Yeah.
Yeah.
Can you run 1.2 miles?
Yeah.
Can you run 1.3 miles?
No.
Can you run 1 mile?
Yeah.
Can you run 2 miles?
No.
Right? Like, is there every opportunity in between it? Right? It's fluid. This is a continuous graph. If Julie is running a race, that's a measure of distance, correct? And what's changing about Julie as she's running this race? Her speed or her energy, right? The how fast she goes. So when she starts, or I guess we could say that this is time, distance, right? The total what we're measuring is where she goes. Yes? Okay. So here's Julie. She starts the race and she gets up to her cruising space, right? She starts. You don't just all of a sudden are at 0 and then bam, you're running at 6 miles an hour. You have to, you have to accelerate to it, right? You have to get going. And then once she happens, she hits her stride. What's she going to do? She's going to stay there, right? So what's going to happen? It's going to flatten out, yeah, because she's running. And then all of a sudden she's like, whoo, this is a lot.
And then she drops.
She goes down because she slows down. She slows down. She catches her breath. She can see the finish line. And then what does she do? She sprints. So what's that going to look like?
Up.
It's going to be a big spike. It's going to go up. And then she's done with the race. She may, stop abruptly. She may jog a little bit to slow down. Or she could just be done, right? Your graph can stop right. Our x-axis is a little long, right? But, that's her speed. And then she is done. Continuous, discrete. Do you see the difference? Here's one that throws people off all the time. If you're measuring the height of Mrs. Long from birth till now, would that be a discrete graph or a continuous graph?
Continuous.
Right? Because it's not like I'd go to bed and all of a sudden I'd wake up the next morning and bam, I was 2 inches taller. If you were going to graph my height change, right, it would go up and then it would stay the same. And then over time, I might get a little bit shorter. But I'm not going to go down to 0.
I will.
If you're measuring your fingernails, what is that? Continuous, because your fingernails are always growing. I can't watch them grow, right? It's so slow. But what would the life of your fingernails look like in a graph? It would go up, right? Would it go up quickly?
No.
No, it'd be really slow incline. Then a sudden cut off because you trimmed them. And then it would keep, but even like that moment, like you cut them, they're still growing, right? Same thing with your hair. But if I was measuring, if I wanted to know, if I wanted to know the temperature outside, continuous or discrete?
Continuous.
Why continuous?
Because the temperature's always changing.
Because the temperature's always changing. When it is 60 degrees in the morning and it turns to 80 degrees at noon, is it just like BAM! 20 degrees.
No.
Yes.
Sometimes.
Exclusively in Kansas.
Right, maybe in Kansas.
Random weather ever.
I mean, it's fall right now, and like.
If I was trying to figure out how many people were on the bus at each hour, right? At 10 o'clock, how many people are on the bus? At 11 o'clock, how many people are on the city bus? At 12 o'clock, how many people are on the bus? Is that discrete or continuous?
Discrete.
Discrete, because I'm not going to have in between numbers, correct? So when we're writing about these, we need to determine, is it discrete or continuous? Sometimes that's the hardest part, you guys, is deciding, is this a discrete or a continuous graph? After you decide, is it going to be discrete or continuous, you need to break it into sections. And those sections are up, down, and flat. We have to do this with buddies because, you know. Up, down, and flat. And then we're going to match words. We're going to match words to each section. If you were looking at a graph, a picture, and there was a section that went up, what are some words that you could use to describe going up? Jameson?
What she said, increase.
Increase. Oshik?
Rise.
Rise. Greater. Yep. What if we were talking about weight?
Fat.
Gained. What if we're talking about down? Dropped, decreasing, loss, slowed, something falls. Is there a difference between quickly increasing and increasing?
Yes.
Yeah.
So what's that called? What's the difference between those in a picture? Show me quickly increasing with your arm. Show me slowly increasing with your arm. What changed?
The speed.
The speed, the slope, right? The angle. So you have to look at the angle. Is it quickly increasing or is it slowly increasing? What are some words that could mean flat?
Straight.
180 degrees.
In a story, what words could mean a flat part of the graph? Jameson?
An even.
Evened out?
Yeah.
Morgan?
Steady or consistent.
Steady, constant, consistent. Rashik?
The origin.
The origin, right? original. Plateau, if you remain still. All right, on page 20, you're going to glue that piece of paper that I gave you. Page 20 is where you're going to glue that piece of paper I gave you. And then as a table, you're going to answer those 5 questions and then compare with your table. And if you can do this, you're going to rock your homework. But this gets glued on page 20.